Hello guys. So my name is Armen, and once upon a time I became a Solidity developer, and that was like about 5 years ago, or more. I don't really remember. And yeah, I think that's like everybody can hear me just like this. Thank you. So actually, today I'm gonna show you some, like I would say, simple hints from a developer's perspective. But it may be hard for just ordinary users. But I find it's really important to know. So actually, the idea came to me because of my practice. You know, I have a lot of crypto friends. I have like a company clients and crypto communities who like keep asking me questions like, can you please help me with that or with this? Can you please fix my transaction? Or can you like show me how to interact with the smart contracts or something like this? So for today, I chose 3 cases that I had in my practice. Like some of them I had like multiple times, and I was helping people a lot to solve them. And some of them are like let's say less common, but still interesting. So like, and today in real life, I'm gonna show you something. I'm gonna show you those cases and how to solve them. So let's go. So the first case is about, like, it's really simple, about canceling your transaction. Imagine you have an Ethereum transaction, and it's stuck. So you just put like less gas in it, so not enough. And you want to cancel it because you want to send a new one. And of course, like obviously, Ethereum works the way that you cannot send another transaction if one is not finished yet. So you need to cancel it. But for example, imagine you send it from some I don't know, some wallet from the application or something, and it's not really shown in your MetaMask history, for example. For that, we need to cancel that, right? So for that, we can use, I will use MetaMask, but you can use any other normal wallet, let's say, which allows us to have some developers tools in it. And so I'll show it in practice. Here I have my wallet. It's on the testnet, and let's choose maybe go early. That's gonna be better. Yeah, so here we have, and let's send this stuck transaction first. For example, let's we need just anything. We'll just choose any transaction. So it's from my address to my address with some, I don't know, 0.1 Ether. And yeah, we also need to put less gas in it. It's somewhere here. So right now we can see that normal gas is 22 G ways, and we will put something like I don't know, 7, right? Or even less, 5. It's not going to be enough for sure. And let's go. Let's send it out. So here we can see that it's pending. And spoiler, it's going to be pending for really, really long. And yeah, right now, yeah, I have this transaction in my history because I sent it from the MetaMask. But imagine if you don't, and you need to cancel it. So how we do it? For example, we can take any, I will tell a little bit about theory about that. So how it works. For example, let's take some previous transaction from my address. And we can see that every transaction, it contains some fields, some arguments in it, and they're always the same. And you probably know about transaction hash and from to it was sent, where from and where to. But also there is one field that's called nonce, and not a lot of people know about that. Hello. Yes, but this is crucial. Actually, this nonce is just a counter on your account that shows how many transactions you actually sent. And it increments all the time, all the time. And you really cannot send a transaction with the nonce that is higher than your current nonce. So for example, my last transaction from the address was with nonce 37. And it means that the next one gonna be 38. And yeah, that transaction that is pending, it is with 38 nonce. So actually, I have transactions somewhere in mempool with nonce 38. And what I will do, I will just replace it, because this transaction is not mined yet. So actually, it's not existing in the chain. It's only in the mempool. So the chain doesn't know that it's existent. And I'm going to just send another transaction with these nonce, and I'm going to just replace my current one with a new one. And this way I will cancel, and that one will just disappear. So let's check it out. I will open this transaction. Here it's still pending, nice. And I will send a new one. And for that, you just need to send like a simplest transaction possible. So you take your address and send from your address to your address 0 Ether. And it works for every transaction. Like imagine you were sending some tokens like interacting with smart contracts, whatever. Doesn't matter. You will just need to send this kind of transaction with the proper nonce. And the proper guess. That's also important. So yeah, it's like this field is not really usually shown, but you can find it in your like MetaMask settings. You can find like something like toggle, like something show like customized nonce or something like this, and you just need to put it on, and then you will be able to customize nonce. So as you can see, it shows me like 39 because it thinks that's I had a transaction at 38 nonce, but we will gonna like fool it and put 38 here, and send the transaction. Let's go. Yeah, and I don't know for what reason, but MetaMask sometimes it fails. Exactly with this kind of transaction. I noticed it when I was testing it. So like we just need to send it twice, but I don't know for what reason. It's just some strange stuff. So. Did it send it? I'm not sure. Maybe it sent. Oh, come on. Should be sent. Okay, here's the one that's pending. Yeah, with 0.1 adder. Come on, what happens? Okay, let's send a little bit the other transaction, like 0.2. It's still to my address, so it doesn't matter. And with nonce, that is 38. Ba-bam. For some reason, it's not sent. Interesting stuff. Sorry, it worked before. Shit. Because 37, it was the last transaction that I sent, and it's already mine. So like I sent this pending transaction, so like this transaction is gonna be with 38. So like Etherscan doesn't show it right now, but it is with 38. And I just need to replace it. And yeah, that worked before. I don't know, mathematics is just stupid. Okay, let's generate like completely different transaction. Let's choose some random address with 0 adder. Click next. We'll take an aggressive gas price with nonce 38. Come on, man, work. Oh, finally it worked, I think. Right? Yeah, so we can see that it's a different transaction here. And so yeah, it should be mine soon. We'll wait for it. Come on, let's go. I just want to show you what happens next. Okay, so I can show you that the transaction hash is actually different. Oh, it's mined, finally. So it is mined, and we can see that nonce is 38 here on the second transaction. And let's check the first one. What happens here? It disappeared, as it was never existing. So, and this is the way you can cancel your transaction easily. Not easily, because MetaMask, as you see, it's bugging for some reason, but yeah, it is possible. So yeah, that's the first case. And it's really common in my practice. Like a lot of people, they ask me about that. Let's move to the second one. It's a little bit more techy, but still, I think like if you had some deal with smart contracts, it's going to be useful for you. So imagine you have a smart contract in the network, and you know what's there in that smart contract. You know that there is some function that you want to call, and you want to extract some data from the chain. But imagine if it's not validated on ETHDam, so you don't have any interface to it, and you don't know how to interact. And you actually don't know how to code, so you cannot really open just VS Code easily and write some script to extract it exactly from chain. That's not that easy, even for me if I don't know the interface. But in this case we know the interface. So for example, we will have a contract, smart contract. So here it is. It's really small, tiny. And everything that it does, it stores some number in storage. We're gonna deploy this contract to the network, and then we're gonna get this data without this smart contract being validated on chain. So I will use Remix, and you will mostly possible will be using it too. Let's choose something like Sepolia because it's faster. And yeah, here we are. So we just can Remix. It's it's IDE. So you can just you can write some Solidity code there, and it's really easy to start using it. So that's why I chose it for this example. Let's deploy this contract. So as I said, here we have two functions. One of them is a setter, and it's gonna put some data on chain, and the second one is getter, which it's gonna extract this data from chain. I'm gonna deploy it on Sepolia network. Wait until it's mined, of course. What's taking so long? So here we have it. So Remix, it provides us an interface of the contract that we just deployed. And we can put some number there, for example, 55555. Let's set it on chain, so it's gonna be stored in storage. Again, let's check it out. Sorry, I will put some aggressive gas price next time. Come on. Okay, so here we have it. And right now we can call getter, and we will get this number. Can you see it here? So it's here. And we will have our smart contract address, actually. It is here. It's deployed on the network. So you can see it is a contract. So we have an address. And imagine you have an address, and you know that there is some specific smart contract behind it. And you know there is a function that you can call to extract some data. But you cannot do that because it's not validated on EtherScan. It's just some strange bytes, all right? We cannot send any transactions here. And imagine you don't have this interface. We'll delete it. And right now you just need to, there is a function and you want to extract the data. So what you can do? You can create not even a contract, but the interface. It's really easy to do. And we'll do this in some test file, for example. It is some coding, but it's some really simple coding. And we're going to create an interface. Interface something, whatever. It can be anything. All we need is that function that we know that's existing. And for example, you need the function looks like this. So we just take this function. And we create the interface with this particular function. Boom. Okay, it's compiled, nice. And what we're gonna do, there is a field which is called add contract. So you can use an interface at some specific contract address. And we will take this address exactly from chain. We will put it here behind that interface at address, and we will have like not that smart contract. We will have like something that is called something. So the interface that we just wrote, and if we call this function here, imagine what happens. We get the result that we actually put from that smart contract. So this way, like we got data on chain without really knowing the full smart contract and without it being validated on chain. And the data is the same, like you can see, our 5 that we put there. And that's really easy. Like if you know any function, for example, it's really common that smart contract has a function that is called owner, because a lot of smart contracts, they're ownable. They have some owner. And you can just put here like the function that is called owner. Function owner. And it should be like external view, which returns address. So, and this way we'll be able to extract any owner from chain, if it has an owner, of course. So yeah, here we are. And also I have the third case for you, which is less common, and I don't think I really have enough time to show it. But I'll at least tell about that. So like I tested it a few days ago and it worked. There is a possibility, you know, like right now we have a lot of ETHDam chains actually. And all of them are kind of the same. So we get like the same Ethereum addresses, we get like the same accounts, the same smart contracts and so on. And sometimes, like I remember, that's actually a case from my practice. So some of the company clients, they came to me and said like, look, we have an address of our smart contract in the Ethereum network, and then like somebody from our like users, they sent a lot of money to the same address, but on BSC, and I was like, shit, because this address, it's not existent. There is no private key for this address because it was not deployed to BSC. But the thing is, it's partially possible to extract this if we deploy the right smart contract with the right data there. So actually, this contract address that we deploy doesn't really depend on the bytecode of the smart contract. So you can write there like anything you want. It actually depends only on your address that you're deploying the smart contract from, and the nonce, again, that nonce from like my first case. And if the nonce and your address are the same, then the smart contract's address is gonna be the same. And yeah, actually, for example, I prepared a contract that's called withdrawer. So basically what it does, it's also really tiny. What it does, it can withdraw from its address any ERC20 token and any amount of native token, so Ethereum, for example, or BNB or whatever. And for example, let's say you have like a nonce on Ethereum network that is like 30 or 40, okay? It's 40. And then your address on BSC is empty, so it's 0. And then you just need to send like 39 transactions from your address, so your nonce becomes 40. And then you need to take these smart contracts. It's going to be not the same smart contracts which we had on the previous network, like on Ethereum. But it's smart contract that can withdraw basically anything. You can also add here NFT, so that's not really hard. And then if there is some funds on that address in BSC network, with on this address without any contract, without any private key under it, we will deploy this withdrawer contract to that network with nonce 40, and we will get exactly the same address that we have in Ethereum address. And yeah, from my case, actually, I remember in real life, I performed that, I deployed the contract on BSC with the same address, with the same nonce, and I was able to extract money from it, and we returned it to the user. Ta-da! So yeah, I think that's it. Unfortunately, I didn't have enough time to show it in real life, but it works. So if you want to see it, I can probably show you afterwards. So if you want to talk, come to me, and yeah, we'll show you everything. Thank you.